Today's lesson is about solving and graphing rational functions. These are the odds from a different worksheet. Just do the odds. If you have odds and evens, stick to these. Okay, problem number 1. The x-intercepts. Normally with a rational function, I get the x-intercepts by setting the numerator equal to 0. But 1 cannot equal 0. It's already 1. Yeah, what's happening here is there are no x-intercepts. All right? There must be an asymptote. So x-intercepts, none. Y-intercept. I get the y-intercept by letting x be 0. So basically, if I substitute 0 for x like this, then this is going to become 1 over 2. So that's why my y-intercept is 0, 1/2. And I can go ahead and plot that. 0, 1/2 would be right here. Now let's talk asymptotes. All right, vertical asymptotes. How do I find vertical asymptotes? Well, for a vertical asymptote, you take the denominator and set it equal to 0 and solve. So I do x plus 2 and set it equal to 0. If I solve this, I get x equals -2. So that is my vertical asymptote. All right, next it's time for the horizontal asymptote. Now, for the horizontal asymptote, I look at the degree. If the numerator degree is less, the asymptote is y equals 0. If the numerator degree and the denominator degree are equal, then I just make a fraction out of the leading coefficients, and that is my horizontal asymptote. If the numerator degree is greater, then there is no horizontal asymptote. There might be a slant asymptote, but we'll get to that another day, not today. So let's see, which situation are we in here? Well, look, when you just have a constant, that's degree 0. There are 0 x's up here. Down here, this is linear. This is degree 1, 1x, x to the 1 power. So this is the situation where the numerator degree is less than the denominator. And we decided if the numerator degree is less, then y equals 0 is the asymptote. Okay, so the horizontal asymptote will be y equals 0. Please make sure you put y equals 0. Don't just put 0. For the vertical asymptote, put x equals -2, not just -2. Anyway, let's graph the horizontal asymptote. All right, it's time to plot some points. All right, we will plot this many points at a minimum. All right, 1, 2, 3, 4, 5, 6, 7. We will plot a minimum of 7 points, people. Okay, we need at least 2 points on the left and 2 points on the right. So of the vertical asymptote. So I'm definitely going to do -4 and -3 for sure. Okay, -4 and -3. You know what? I'd like to see what's happening really close to the asymptote. So I'm going to also do -2.5. See what's happening halfway, close to the asymptote. So -2.5. Similarly, on the other side, let me do -1.5 because that's really close to the asymptote. I want to check that out. See, this was 2.5. Let me do that better. Okay, so -2.5 and -1.5. Okay, we've already got that, so that's good. But let's also do -1. We've got 0. So let's do +1. And why not also do, that's going to give me a few points over there. Let's just do 2. All right, I want at least this many points. So I'm just going to put the function into my TI-30XS multiview. 1 over x plus 2. Okay, and I can scroll around and get most of these values like this. Okay, so I'm going to get all the values that I can, the integers. I'll just scroll around and get them off of the table. I'll do that off camera. All right, so these are the values that I pulled right off of the table of the calculator. They're integers. Now, what about these decimals? Okay, hit your table button again, hit enter again. An easy way to get some decimals is to use the ask feature. So I'm going to choose that this time. All right, so it's waiting for me to ask for which x values I want to evaluate. So negative 2.5. Okay, so that's negative 2.5. So that's negative 2. And negative 1.5. And that's positive 2. All right, so the ask feature is very handy when you need to evaluate some decimals. So don't forget about that. All right, so now I'm just going to plot each one of these points, and I'm just going to plot them on my graph. I'm going to do that off camera as well. All right, I've now plotted each one of these 7 points, and they are the 7 pink points that you can see right here. The purple one was the y-intercept 0, 1/2. Okay, so altogether I guess I have 8 points that I'm graphing. All right, so they give me a pretty clear picture of what's going on. So I'm just going to draw this branch here, and I'm going to draw this branch here. All right, so your graph should look something like this. Now the domain, that's the x values, reading it from left to right. All the x values are included on this graph, represented, except for the vertical asymptote. So everything except for negative 2. So I'm just going to go from left to right. So I have from negative infinity to negative 2, basically the domain of the left branch. So negative infinity to negative 2. And then union. And then I'll pick up from here with the right branch, right? So it skips over negative 2. That's why I leave this around parentheses. But then it picks up from negative 2 and goes from negative 2 to infinity. So that's the domain for this graph. Similarly, the range, that's the y values of the graph, and we read it from bottom to top. So all the y values are represented except for the horizontal asymptote. So everything except for 0. So I'm going to go from negative infinity to 0. And then from 0 to positive infinity. That'll be the range. Now, increasing and decreasing intervals. Remember, we have to read this from left to right. So as I trace this branch from left to right, see what's happening? It's going down. So this is a decreasing interval. So from negative infinity to negative 2. Remember, I'm looking at the x value. So you might have been thinking negative infinity to negative infinity, maybe. I don't know. Because a lot of kids, when they see it going down, they want to say negative infinity. But no, we're just looking at the x values, please. So this part of the graph goes from here to here on the x-axis. Okay, so from negative infinity to negative 2, just the x values. And that was a decreasing interval, so negative infinity to negative 2. Okay, now this other branch, it's going to pick up from here, and I'm going to the right, so let's see what happens. Down. Okay, so this is another decreasing interval from negative 2 to infinity. Again, just x values, so negative 2 to infinity. So basically, the entire function is decreasing, decreasing, and again decreasing. So increasing intervals, none. Symmetry. It's trying to have origin symmetry, rotational symmetry. It does have rotational symmetry, but the center of rotation is -2, 0, not the origin. So therefore, this does not have odd symmetry. It's close, so we will just say neither. It's neither even nor odd. Okay, doesn't have even symmetry either, because even symmetry is like butterfly symmetry, where it's identical mirror images on the left and right of the y-axis. Okay, the y-axis is not the axis of symmetry. All right, so that's it for problem number 1. All right, I'm going to go ahead and squeeze in problem number 3, even though it's going to make the video a little bit long. Note that having a negative here is a reflection over the x-axis. Okay, so number 1 and number 3 should be the same graph, except for it should be reflected over the x-axis. So this branch should be up here, and this branch should be down here. Everything else should be the same. Okay, so x-intercepts. There will, again, just like last time, there won't be any x-intercepts. None. Normally we get the x-intercepts by setting the numerator equal to 0, but -1 cannot equal 0. So none. Y-intercept. We get the y-intercept by letting x be 0. If I let x be 0, then this becomes -1 over 2. That's why the y-intercept is going to be 0, -1/2. Always express the y-intercept as an ordered pair. All right? So, and let's go ahead and plot that. 0, -1/2 would be right here. You know what? I'm going to graph it in purple to differentiate it from the other points. So there's my y-intercept. Now, vertical asymptotes. Vertical asymptotes happen when the denominator is equal to 0. All right? That's why it's an asymptote, because that's undefined. So if x plus 2 were equal to 0, then that means x would equal -2. So there's my vertical asymptote. X equals, and you must put x equals -2, not just -2. Horizontal asymptotes. Okay, we have to look at the degree and see which is whether the numerator degree is less, equal, or greater than the denominator. Well, if you watched the last problem, the numerator degree is 0 because it's just a constant. The denominator has degree 1. So the degree of the numerator is less, and in that situation, the horizontal asymptote is always y equals 0. Okay, so y equals 0. Okay, so let's go ahead and graph these asymptotes. All right, there it is. Okay, before we can do the domain and range and increasing intervals and all that, we need to actually finish the graph now. So I want you to use all 7 of these values, okay? Always use it. I want you to have a minimum of 7 values. Sometimes you'll need even more, but don't give me any less than 7 values. All right, so I've already got 1 point over here, so that's going to be an 8th value. So how about let's do 4 points on this side and 4 points on this side. Okay, so over on the left-hand side, let's do -5. Okay, -5, -4, and -3. Okay. Now, I saved an extra one. That's 3. I said I wanted 4 over here. Let's also do -2.5. It's always interesting to see what happens really close to the asymptote. So you should always pick at least one value that's less than 1 away from the asymptote. So let's do -2.5. Okay. And just for fun, I'm just going to mark this to show that here's where the asymptote was. Okay, now we have 1 point over here. Let's have 3 more points on this side of the asymptote. Again, let's do a decimal here, really close to the asymptote. So right in here would be negative 1.5. So let's do that. Okay, so negative 1.5. Okay, now let's also do just negative 1. Don't have that yet. We have 0, so let's also do positive 1. Okay, so let's go to our calculator and generate these 7 values. All right, so in our calculator, we'll just do negative 1 over x plus 2. Okay, so I wonder, can I just make this a negative 1? Okay, negative 1 over x plus 2. Oh, whoops, I didn't mean to do that just yet. Okay, for now, you're probably, well, for now, let's just do auto mode. I had switched to ask mode. I'll do that again in a second, but for right now. So, most of my values here are integers, okay, non-decimals. So I can get most of these values automatically off my table. So I'm just going to scroll up and down and get what I need. Everything except for the decimals. I'm going to do that off camera. All right, verify that you're getting all the same values that I'm getting. So I got all these right off the calculator. Now for the decimals, it is helpful to use the ask feature. So come back to your calculator, hit the table button, hit enter, and but this time, instead of doing auto like usual, let's do ask. Wait, I didn't mean to go back. Okay, you might not have any values here. It doesn't matter. Ask allows us to type in whatever we want. So I want to know what's happening at negative 2.5. It's already there, but I could just type negative 2.5. Okay, so at negative 2.5, it's 2. And at negative 1.5, it's negative 2. Okay, so try using the ask feature when you need to find some decimals, some weird numbers. All right, so let's just graph these 7 values on the graph and see what it looks like. I'm going to do that off camera. All right, drum roll, please. I've now plotted these 7 values. These are the points that I got. So this shows pretty clearly what's going on in here. All right, it must be doing this type of a thing. Okay. All right, so your graph should look very much like that. Now the domain is the x values of the graph. So the domain includes all of the x values except for the vertical asymptote, which is at negative 2. So basically do the domain of each of these branches separately. So the left branch goes from negative infinity to an x value of negative 2. Of course, it never reaches negative 2 because it's the asymptote, thus the round parenthesis. Union. Now the other branch picks up from negative 2 and goes to positive infinity. So negative 2 to infinity. Similarly, the range is the y values of the graph. So bottom to top, all the y values are represented except for the horizontal asymptote, which is at 0. So it goes from negative infinity to 0, and then from 0 to positive infinity. It has to be in this order, okay? It's got to go from bottom to top. So negative infinity to 0, union 0 to positive infinity. Now, increasing and decreasing intervals. Let's start from left to right. As I go from left to right and I trace the graph, it goes like this. See what happened? It went up. So, that's an increasing interval from negative infinity to negative 2. Now, you might have been thinking negative infinity to positive infinity because it goes up forever. But remember, we're only doing x values here, okay? The x value of this arrow is negative infinity. Now, the y value of this arrow is positive infinity. But what's the x value? That's right, the x value is negative 2. So, negative infinity to negative 2 x values. Negative infinity to negative 2. Now, this other branch, x values again, so this picks up at negative 2. Okay? Don't say negative infinity, that's the y value of this arrow. The x value is here, negative 2. All right? So negative 2 to infinity. These are the x values, negative 2 to infinity. So union negative 2 to infinity. Okay, because as I trace this, it's increasing. Okay, so there are no decreasing intervals, none. Okay, and this does not have any kind of even or odd symmetry. It's close to being odd symmetry because it has rotational symmetry around this point, negative 2 comma 0. But to be odd, it has to be the origin. So we're going to go ahead and say symmetry, neither. Okay, luckily that's the end of problem number 3. And I wanted to stop this video here anyway. We'll pick up the next video with number 5 and number 7. We'll see what interesting things go down. I'll see you on the next video. Don't copy. Make sure you're doing these problems yourself, you guys. If you copied off me just now, redo it by yourself. Make sure you can do it yourself.